Hallo.
Hello.
Hello.
Hallo.
Hallo.
A look, a word,
Hallo.
a first impression. And straight away we know, I can trust her, but not him. She's lying. And so is he. But he seems reliable.
Na, hallo.
The level of trustworthiness that you perceive in another person's face, even when they're complete strangers, can predict criminal sentencing decisions, including up to capital punishment, can predict hiring decisions.
A brief glance at someone's face or the sound of their voice can affect our decisions.
Gathering information from facial and vocal cues has been fundamental to social interactions. Language has only been around for tens of thousands of years, which in evolutionary terms is no more than a blink of the eye.
First impressions can be alluring, but often deceptive.
I'm looking forward to tomorrow.
Our face and voice reveal a lot about us. Our mood, our disposition, our health. They point to what's going on inside us, and the cues they give can even be interpreted by artificial intelligence.
Science fiction has been predicting this development for ages, but it's still hard to fathom, and it leaves us feeling skeptical and uneasy because we're not used to it.
We encounter strangers every day. A new face, an unfamiliar voice, both unique and distinct. They express our individuality, but they also help us decide whether we like the person and whether we accept or reject their advances. Decisions we make instantly.
With just 100 milliseconds of exposure, people already make up their mind about trustworthiness and competence and dominance. But that making up their mind takes, several hundreds of milliseconds. But you only need a very quick glance. There's certain facial features, even in a static photograph, that convey levels of intelligence, and that can lead to judgments and biased decisions.
John Freeman is looking at what happens in our brain after a short glance at someone's face. His theory, many of these instantaneous decisions are based on learned stereotypes. The same applies to voices. Pascal Boulon continues to find evidence that we associate certain emotions and traits with how someone's voice sounds.
We see voices as a type of auditory face. We need just one word to form an opinion. A voice like this is seen as inspiring and confident by most people, whereas this one leaves the listener thinking they wouldn't trust him with their money.
Hallo.
Hallo.
Hello.
Hello?
What does science say? Do we all see the same thing when we look at someone's face? John Freeman uses a special morphing program to get a more accurate answer. He can alter gender, age, mood, and character traits subtly.
If you ask hundreds of different subjects to judge the trustworthiness of these individual faces, you'll find that they generally agree in terms of being highly correlated with one another. So the same faces appear trustworthy or relatively untrustworthy across the board generally.
Although we're all different, the result is surprisingly similar for everyone, at least if we're asked if someone is trustworthy. The first impression is when we decide who we want to communicate, cooperate, or form a close relationship with.
Is it surprising that people have these kinds of unconscious tendencies despite humans being such rational creatures? I would say not really, right? When we think evolutionarily about, in terms of our evolutionary past, before we had verbal language, right, as non-human primates, nonverbal communication and using facial appearance, using cues of the face, voice, and body were really critical, right? For survival, for the maintenance of resources, for building social groups.
It can be attributed to our evolution. Making instant decisions about who is friend or foe greatly increased our chances of survival. As pack animals, we've always formed communities. Long before language played a role, humans developed a keen sense of how those around them felt. And being able to read the room is a huge advantage. If someone in the group is scared, your own life may also be in danger too. If someone is seething with rage, you placate them or run. Our brains are still wired the same way today. As soon as we encounter someone new, we immediately attempt to establish whether they are with us or against us.
But to what extent do these first impressions actually alter our behavior? The evidence shows that they have a strong impact.
Ça a vraiment un impact très fort, ces premières impressions.
They predict all sorts of downstream social outcomes and real-world consequences. And so, when the findings like faces that appear more competent are more likely to be elected to senator and governor positions in the United States, and even presidential candidates are more likely to win in the United States.
Competent-looking managers and attractive people are paid more, and defendants who look untrustworthy are given longer sentences. But what about our voices? We can hear fine nuances of confidence, dominance, and competence too, even if they have little in common with the speaker's actual personality. Beyond words, a voice also transports emotions and can even bring things to life. Puppets become real figures we relate to like other human beings.
Ça illustre complètement cette...
It illustrates how we instinctively relate to a human personality if it has a voice.
N'importe quoi, à partir du moment où on lui donne une voix.
On a puppet, for example, and because of changing body cues and changing vocal cues, that the perception of the emotion, the perception of that person's or the puppet's intentions are changed.
Oh, yes.
Look me in the eyes.
Just a little bit. Generosity.
Sympathetic.
Ambivalent.
Our brains create real people from the voices they hear, even when the people aren't real.
Once you give a machine a voice, it gets a personality as if it were human.
Comme si c'était un humain.
It's an automatic reflex.
Quasiment automatique. Il y a des recherches qui montrent que dès qu'on donne une voix...
And research shows that people's feelings change if their computer, car, or coffee machine has a voice.
Et du coup, le contenu de cette voix...
The vocal acoustics we give machines could even determine how we interact with them.
Être déterminante dans la manière dont les humains vont interagir avec la machine.
Furhat, wake up. Wake up.
How can I help you?
What can you do?
You can, for example, ask me to introduce myself or to chat a little.
Can you introduce yourself?
I'm a Furhat robot, a social robot built to interact with people in the same way you interact with each other. So I can smile and nod.
Gabriel Scancer is one of Furhat's creators. A first prototype of the robot was launched in 2011.
I looked a bit more crude back then with cables sticking out from my head. They came up with the idea to cover the cables with a fur hat. And that, ladies and gentlemen, is where the name fur hat comes from. I don't really need my fur hat anymore. I look pretty as I am, don't you think?
I don't know what the original interest comes from, really. I just think it's a very fascinating idea of creating an agent that interacts like a human and behaves like a human. It's fascinating by its own right, but it's also, again, back to the idea that if we can do that, we start to get a better understanding of how we as humans work.
In the future, Gabriel Scancer wants Furhat to behave like a human during a conversation. But as soon as scientists try to transfer our human behaviours to machines, it quickly becomes apparent how complex our behaviours are.
But I'm originally from the United States.
Do you like being on
Today, Furhat is supposed to make small talk. The robot searches the web on its own for responses.
What do you mean by that?
You are quite stupid.
That's a pretty rude thing to say for Hat.
So I have no idea what the robot will say next. So it's a surprise for me what it says, and it's a bit fascinating to see how the conversation unfolds.
Although the conversation takes some unexpected turns, Furhat has already mastered the basics: when to speak, where their conversation partner is looking, and how much eye contact is appropriate. The scientists have programmed Furhat with a whole range of emotional facial cues. However, the finer differences we express using mimic and our voices are proving trickier.
So as humans, for example, we have these micro expressions. So my eyes move a little bit all the time. I make small movements with my face. And we want the robot to have those small movements also. Otherwise, it looks very robotic and not very human-like. So we think that the face is extremely important, and the way we give feedback to each other and everything is expressed through the face, but also through the voice and the way, the tone of our voice and so on.
That's why it's so difficult for Furhat to react appropriately. The same word or the same sentence can come across very differently depending on the mood, the occasion, or the person we're talking to. Unfortunately, there's no user manual for humans that Furhat can learn from. Not yet, anyway.
There's plenty of cases where, you know, a face can be identical and the same features, but the context, the body, and the voice dramatically changes how we understand that person. There's all sorts of different kinds of cues in terms of intonation, pitch contour, formant characteristics that change how we perceive other people's voices, the emotions that they're feeling, their intentions.
How do we read moods? Mark Schwertz is researching how tiny movements in our facial muscles can influence our communication. The eyebrows, cheeks, lips and chin all contribute to forming very different types of smiles.
It's very subtle because it has to do with micro expressions that you see around the eye region or the mouth region. Or you can fake a smile, like if I do this in a very fake manner, you can see that the person is pretending to be happy or being cynical or sarcastic, but it's not revealing what his or her true sentiments or emotions are. And it's not only smiling; it's also in the very subtle movements of eyebrows, the very subtle movements of blinking.
A recent US TV show focused on body language. Dr. Lightman was the protagonist of the crime show Lie to Me. He was an expert in micro-expressions who believed facial expressions could expose lies and suppressed emotions.
Huge scorn, shame and shame, contempt. These expressions are universal.
Can we really identify every single emotion just by practicing? Some scientists think so. Apparently, all we need to do is consciously notice each millisecond-long facial expression. The results are used in market research to find out which commercials are most effective. Specially trained security teams at airports also analyse facial cues to spot potential terrorists. But is it really that easy to tell when criminals are lying? Hollywood wants us to think so.
43 muscles combine to produce a possibility of 10,000 expressions. Now, if you learn them all, you don't need a polygraph.
How much did we spend on this damn project?
But the scientific world takes a slightly dimmer view.
In real life, it's often much harder to do. So for instance, there are these claims that from your micro expressions you can see whether someone is lying or not, but that's close to impossible. So for most times that people lie about something, you're close to chance level about guessing whether or not someone is speaking the truth or not. Ironically speaking, if your lie becomes more important, like if I'm lying about something which really matters, like I have to hide something, it's called the pink elephant effect. Your cues to lying become clearer for the other person. So the more you try your best not to show that you're lying, the more likely it is that people will see that you're lying.
How easy is it to tell when someone is lying? Mark Schwertz is looking to children aged 5 and over for the answer.
Yeah?
The children are asked to tell the prince in a computer game the truth, but lie to the dragon.
Ik vraag het nogmaals. Waar is de prins? In de toren.
They're supposed to help the prince hide from the dragon. Cameras and microphones record the children's behaviour in an attempt to find any differences.
Daar ben ik weer. Ik hoorde de draak.
After recording numerous children, the results highlight signs that point to lying.
Waar zit de draak?
In de toren.
Mooi. Dan doe ik de deur op slot.
When you look at the face, when they're being truthful, they have a very open and spontaneous kind of expression. When they're lying and they have the impression that they're being watched and being observed, you see that they have this sense of, oh, I'm being observed. And you can tell also from facial expressions around the mouth area, which is more marked kind of expression than in say, the truthful condition. It's something about the voice. So when they're being truthful, they have a very soft, normal, warm voice. When they're lying, they tend to be a little bit more using creaky voice, like talking a little bit like this.
But not every child showed the same cues, so it's not a reliable way to tell if they are telling the truth or not.
Mooi. Wat? Dat meen je niet. Waar zit de draak?
In de toren.
Generally, we're much better at controlling our facial cues than our vocal cues. Every sound we produce is created by over 100 muscles all working closely together. Emotions alter muscular tension, which impacts the tone of our voices. Everything is controlled by different parts of the brain. The muscles in the chest and abdomen that create the required air pressure. Muscles in the tongue, lips and face that vary the voice and, of course, the larynx and vocal cords. The higher the pitch, when we become excited, for example, the faster they vibrate. But does everyone hear the same thing when a stranger talks to us? Do we all come to the same conclusion in deciding if someone is trustworthy, extroverted or willing to try new things? Björn Schuler is conducting research using a range of different voices. Although the group doesn't agree on everything, the data shows some clear tendencies. Artificial intelligence is being used to help identify them.
My theory is that if a human can hear something, a computer can pick up on it too. But it becomes a little spooky when we go beyond what a human can spot. We're now trying to assess whether the speaker has COVID-19 or not. Plus for yes and minus for no.
Covid-19. Strickt sich Nordwind und Sonne. Gut.
We've got one vote for positive.
It was negative.
Here's the next voice.
Einst stritten sich Nordwind und Sonne.
We now have 3 positives and 1 negative. I'm going to say positive. Maurice?
Yes, that's right.
Diagnosing COVID by simply listening to someone's voice sounds risky, at least when we rely on the human ear. At the start of the pandemic, Björn Schuler programmed a range of voices into artificial intelligence. Is a more accurate diagnosis now possible?
This is the asymptomatic negative case.
Negativ. Jetzt haben wir hier den
And this is the symptomatic positive case.
Und was man jetzt hier zum Beispiel rechts sehr schön sieht, sind diese Obertöne. Die sind hier sehr ausgeprägt, klar.
What we can see quite clearly on the right here are the upper tones.
Stark verwaschene. Das heißt, das ist eben dieses Rahl.
There are lots more signals we can use too, like the uncontrolled vibration of the vocal cords that leads to irregularities in the stimuli, a certain throatiness, breathlessness that causes longer speech breaks.
Die zu Unregelmäßigkeiten in der Anregung, in der gleichmäßigen Anregung führen, diese Rauigkeit, kurzer Luft haben, deswegen längeres Sprach-Pausen-Verhältnis zugunsten der Pausen.
All these things give the computer enough examples to reach a decision and differentiate between asthma or a cold.
Eine Entscheidung treffen kann, die sich auch zu Asthma, Erkältung abgrenzen lässt.
At least 85% of the diagnoses made by artificial intelligence were correct. What's more, computers can also identify ADHD, Parkinson's, Alzheimer's and depression by analysing voices. Anything that goes wrong in the body or brain impacts our voices. To make a diagnosis, artificial intelligence looks at up to 6,000 different vocal cues. The new technology could allow diagnoses to be made more easily and earlier. Every word we say reveals more about us than we realise. And as listeners, we are influenced by the person speaking to us. Subconsciously, we relate to the person speaking. We internalise their anxiety, uncertainty, excitement or happiness as if it were our own. It's a type of synchronization that connects two people through mimicry.
But in general, mimicry is something that we do observe a lot in normal kind of conversations, and it's reflected in various aspects of our communication, from the words we use, the syntax we use, the prosody we produce, so the intonation and the tempo, but also the non-verbal communication, for instance, smiling behavior.
The closer the relationship or desire for a relationship, the more intense our subconscious mimicry becomes. We also mimic more strongly when we want to be liked. A smile is the clearest signal.
The smiling person often triggers something of happiness in yourself. Like if you see a smiling person, you sometimes start to smile yourself. And so I don't know, maybe one of the attractive features of the Mona Lisa has exactly to do with that. Like there's something intriguing, something attractive about looking at the painting because she elicits smiles, she elicits happiness.
We allow ourselves to be influenced by someone else's mood. Mark Schwertz wanted to take a closer look. In this experiment, the speaker is describing something to her audience. Her manner is animated and she smiles frequently. Her audience reacts similarly. They smile back, nod in agreement and give positive feedback. But what happens when the same speaker repeats the process, but more seriously? Her listeners also look more earnest. They appear to concentrate more and their reactions are more constrained. Synchronization signals empathy and interest in the other person. If our communication is successful, we tune into them more closely. And it's not just our facial cues that sync, it's our voices too. Trying to express an emotion vocally that we're not feeling is nearly impossible. So what transforms a voice into an instrument that can appeal to, persuade or motivate other people? Oliver Niebuhr has carried out numerous case studies and all have the same outcome. It's not what we say that counts, it's how we say it.
The voice is an extremely complex, multi-layered signal. We all have information that we want to impart, but absorbing it is hard work from a cognitive point of view. So we need to work on how we present it. Emphasizing words can send a clear signal indicating which parts of the conversation are important. We need to consider short pauses too. In fact, people who communicate like this are regarded as more likable.
Dann ist man wesentlich eher gemocht auch, tatsächlich.
So it's all about how we use our voices to package the content. The phonetician is performing a short test. How well can his co-worker present a text he's reading from for the first time? Artificial intelligence is again used for analysis. The computer calculates a score of 47.7. It splits the voice into 16 parameters, including speed, rhythm, melody, volume, and pauses. A score between 1 and 100 for acoustic appeal is then calculated. Our ears prefer a varied pitch, usually around 2 octaves. Charismatic speakers often switch between loud and quiet, fast and slow. It makes the voice sound more melodic.
And input their start and stop times at the push of a button. But what about employees?
For centuries, this principle has been used by populists and demagogues to capture the attention of audiences. Because even ancient civilizations understood that the only way to motivate and inspire people was to get them to listen.
Public speaking, projecting and modulating your voice to achieve the best result was taught in classic antiquity. Now it's become a lost skill.
C'est un enseignement qui s'est un peu perdu.
It's possible to train your voice to transport information effectively. It's no different to learning a new vocabulary or grammar.
Oliver Niebuhr has developed a computer training program.
After 5 seconds, so know that you have a pitch range.
The principle is fairly basic. The upper and lower lines show the pitch. Circles in different colors and size represent speed, volume, and pauses.
Traveling to different, what I really like to do is to try different food from different countries, and I really like spicy food also.
Users are shown what they can improve in real time.
Well, in the golden time, or in the extra
After one day of training, the speaker tries again.
Good chances to win. And paycheck errors by 90%, saving both
and scores 12 points higher than the previous day.
How does your company handle
the main improvements are in pitch variation.
Clients?
His score has soared from 34.5 to 73.3. That's almost double his previous attempt.
This app has not only
it's a clear improvement.
Time card process for remote employees.
Other voices are so seductive that we can lose ourselves in them, as shown in this experiment. Some drivers were given instructions by this voice.
Folgen Sie dem Straßenverlauf für 300 Meter.
And others by this slightly less engaging voice.
Folgen Sie nun der Straße für weitere 1500 Meter.
Was sie aber nicht wussten, ist, dass auf der Hälfte
What the drivers didn't know was that halfway through the experiment, the sat-nav started giving incorrect directions. And it got progressively worse and worse. We wanted to see at what point the drivers would quit. We were able to show that the more expressive, the more convincing voice kept drivers following the wrong route for longer, despite it going against their better judgment. We had to call them, explain it was just a test and ask them to come back.
Diesen falschen Anweisungen gefolgt sind, wo nachher wir anrufen mussten und sagen, sorry, kommen Sie zurück, das war nur ein Test.
An engaging voice plays a key role when it comes to flirting or meeting a romantic partner.
Hello.
Hello, I'm Willy.
Willy.
Hello, Willy. I'm Cordula.
I'm looking for a woman for the long term.
Who's attractive? Who do we desire? We make snap judgments when it comes to one of life's most important decisions, quickly and irrationally.
Snap judgments have always thought they're really fascinating. It's sort of how we determine who we want to date, who we want to be friends with, who we don't want to be friends with. And we don't have a lot of introspective access to those feelings. What drives that? We usually encounter people and we like them or we don't like them. And we have a good sense of that. We get along with them. And these things determine all of our behavior.
Are we all born with a universal code? Is it nature or nurture that allows us to interpret character traits and read emotions through facial and vocal cues? One thing is certain. We react to these cues from a very young age. Just like our animal ancestors. Obviously, primates never developed verbal language like humans. But just like us, they communicate vocally, and they know how to interpret the signals.
Jusqu'ici, la plupart des chercheurs pensent que c'est très différent.
Scientists have always assumed that there are huge differences between verbal humans and non-verbal primates. But research shows that the auditory cortex in both species is more similar than expected. Whether verbal or non-verbal, it makes no difference on how the brain processes signals.
L'organisation du traitement de la voix. Mais nous, on peut faire une angulation le long de...
Pascal Ballon has tested humans and primates using functional magnetic resonance imaging, or fMRI. The results show that both groups react to their own species' voice in the same parts of the brain. Our ancestors also probably used these areas 20 million years ago. Primates process vocal cues the same way we do, even without language.
The brain's architecture has changed slightly in humans to process language. But the mechanisms have stayed the same in other species for anything beyond language: identity, emotions, personality.
Research into how primates interpret facial cues shows similar results. Again, similar brain structures to humans are activated in the primates. Does that mean that we are born with the ability to understand facial and vocal cues? Joris is 10 months old and is getting ready for an experiment. Sarah Jessen wants to measure Joris's brainwaves to see how he reacts to unfamiliar faces. Can he already judge who's trustworthy and untrustworthy?
We carried out research where we showed babies a range of faces for 50 milliseconds. That's only a 20th of a second. It's so quick, we assumed that babies wouldn't even register the faces. However, we identified activity in the brain that proved the babies had not only registered the faces, but had even made a decision about whether they were trustworthy or not.
But is it innate or learned?
We don't believe that a baby is born with the ability to judge whether a face is trustworthy or not. It's more likely to be a combination of learning processes and an inherent or early interest in faces.
Over the first few months, faces and voices are a baby's most important learning resources. Parents intuitively use pronounced facial cues, emphasize certain words, and exaggerate. This captures the baby's attention and allows them to recognize emotions more easily. By 6 months, babies can already differentiate between happiness, fear, sadness, and anger.
You want to play, I see. I'm still a bit sleepy.
Just like a child, Furhat is learning to understand us better and practicing how to behave in a conversation. He analyses the movements and eyes of his conversation partner using a camera.
My name is Gabriel. Furhat has to know whether I am talking to Furhat or my colleague here. So that's quite tricky, and we call that a multi-party interaction, where there are more than two people talking. And one of the ways of handling this is that we track the head pose of the users. So here we can see that the camera has detected us two here, and it can also recognize our faces. So if I turn around and look back, it will see that I'm the same person still.
It's time to play a game with Furhat.
Gabriel.
The team takes turns drawing a shape, while the other players guess what it is.
Could it be star?
No.
Is it a flower?
Yeah, it's a flower.
Got it. So let's go.
My guess is feather.
No. Just make it more.
Is it a worm?
I know. It is snake.
It is, yes. Go for it.
This is a good one.
A boat.
Keep guessing.
Is it a boat? Isn't it a boat?
Furhat will look and sound more like a human over time, but he won't be identical. Studies show we prefer a clear distinction between humans and robots, or we find it too creepy. The boundaries are already blurred in the media. After 40 years, ABBA is back on stage. Not in real life, of course, but as avatars. It's like time has simply passed the group of 70-year-olds by. Only their voices are still real.
We're at the start of a huge technological shift.
Transition technologique.
We are often asked to record actors' voices.
D'enregistrer des acteurs humains.
I predict that over the next few years, these real-life voice recordings will become superfluous.
De pas me tromper que dans quelques années,
because we'll be able to create new synthetic voices using scientific principles.
Modulable et basé sur des principes scientifiques.
I don't know what you're talking about, Hal.
I know that you and Frank were planning to disconnect me. And I'm afraid that's something I cannot allow to happen.
Artificial intelligence making independent decisions was still a pipe dream in director Stanley Kubrick's day. But today, we live with it. And maybe that's a good thing, because AI doesn't make emotional decisions or succumb to alluring voices. It's neutral and impartial, and everything we're not, right?
If you program an AI, if they see that, African American is linked with hostility and crime in media depictions in TV, and those are inputs into the AI is going to pick up on that and act accordingly.
You'll be shown a series of
So AI is more like us than we realize. In Lie to Me, we're shown how some faces are automatically linked to stereotypes.
What are you guys up to? We're testing for racial bias. Plot the racist.
Oh, they're all racist. Yeah, 80% of people who take this test are biased. We're just looking for the guy who takes the
And science dictates that subconscious bias directly impacts our perceptions.
Association time for each of them.
They leave a lot of collateral damage in the brain, right? It's not just a stereotype living in sort of a filing cabinet in the brain, right? They're changing approach and avoidance tendencies, behavioral tendencies, motor tendencies, visual tendencies, auditory tendencies.
John Freeman is looking at exactly what happens using fMRI. The test group has shown several different faces. As well as the part of the brain responsible for facial recognition, other areas that process social and emotional information are also activated. These areas memorize bias and personality traits. To provide a rapid response, our brains make fast predictions. We register what we perceive to be most probable.
This can often be adaptive, right? If you walk into a restaurant, you expect to see chairs and tables and a waiter, etc. You're not going to waste a lot of metabolic resources, the brain's time, the visual system's resources, and processing every single object in that space. You generate a bunch of hypotheses, you know what a restaurant is, and you kind of run with those hypotheses, and you use expectations to fill in the gaps that the brain is too lazy to figure out itself and doesn't want to waste its resources on.
So are we merely at the mercy of these mechanisms? John Freeman refuses to accept this theory. He's carrying out research to find out how we learn these stereotypes and whether we can unlearn them. He shows the test group a range of faces linked to specific character traits.
So given all that, we wanted to explore our capacity to rapidly acquire completely novel facial stereotypes out of thin air. People that have a wide cilium width, which is the nose bridge on the face, and it's a cue that really has nothing to do with anything interesting. It's just simply how wide the bridge of the nose is. So it's an arbitrary facial feature, and 80% of the time we're pairing this wide cilium with trustworthy behaviors. So now they see completely new faces, not the ones that they had previously learned about, and that have wide and narrow ciliums, that arbitrary facial feature. And indeed what we found was that on a variety of different measures, more conscious, less conscious, that people are applying these stereotypes, they are automatically activating these stereotypes without their conscious awareness from just a couple minutes of learning.
Our brains are highly flexible when it comes to stereotyping. We can learn to evaluate faces differently, at least over the short term. John is now looking into a training method that works long term. The same principle applies to voices.
Ultimately, the more we know about these mechanisms, the less susceptible we are to being deceived by first impressions.
First impressions. Fascinating, sometimes deceptive, but always a special, even magical moment. And maybe the start of a new relationship where we discover so much more than what we saw at first sight.